started to. Here we are in your empty classroom that we'll get a chance to be in hopefully soon. Quick little video on types of reactions. We're basically going to look at just these 6 main types of chemical reactions throughout the rest of the year. And I want you to get comfortable with trying to name what kind of reaction it is and predict the products. And then still be able to balance the reaction, all of that good stuff. Tell me which state of matter it is. And I'll do a little bit of demos. I'll probably cut and paste them into this little mini lesson. First one is called the synthesis. Sometimes you'll see it called the combination reaction, because in a synthesis, you start off with 2 or more substances and they combine to form one. So they combined, combination, synthesis. The general equation for it is you've got A plus X yields AX. Usually the A is going to, you can sort of already tell, we're going to be talking about metals, and the X is usually going to be your non-metals when we're talking about ionic compounds, for example. For example, you've got solid potassium in this case, combines with chlorine gas to make 2 molecules, let's just say it here, 2 compounds, 2 formula units of potassium chloride in a solid form. So synthesis to combine. Back. So decomposition reaction. You've got one compound that's made up of multiple, at least 2 or more different atoms. It breaks, or the same atom, 2 or more atoms, breaks down into 2 or more simpler substances. Okay, so decomposition is going to break apart. It's the opposite of synthesis, so it's an uncombination, decombination. General equation is the other way around, right? So AX yields A plus X. It doesn't have to be just single atom products, because this example will show you calcium carbonate in its solid form can decompose into calcium oxide and carbon dioxide. Right? So there's still 2 simpler ones than the original one, so that still makes it a decomposition. It's still breaking apart somehow. Special decomposition reactions. We've got the decomposition of metal carbonates. So they're going to make a metal oxide. All right, so a metal oxide and a carbon dioxide. Gas, of course. So just like the previous equation. Metal hydroxide. So you start off with the metal hydroxide, hydroxide OH, right? Your polyatomic ion. It's going to break down into the metal oxide, which is simpler than a metal hydroxide, and water. As you can see down here, calcium hydroxide breaks down into calcium oxide and water. But it's still decomposing of sorts. Metal chlorates, same sort of idea. Metal chloride is simpler than the chlorate, and oxygen is released. For example, potassium chlorate is going to break down into potassium chloride and release some oxygen. Or decomposition of acids, similar. So they're going to make our non-metal oxide and water. So we'll get to see that all throughout the year. So here's your carbonic acid, can break down into carbon dioxide and water. Next type of reaction is called the single displacement reaction. So displacement, it's going to replace. In a single displacement reaction, and one element is going to replace a similar element in a compound. So it's usually going to displace a metal. Many of these take place in aqueous solutions. And the general equation is you've got A, some sort of compound A, substance A, BX compound, or metal A in this case, BX, and then the A is going to take the place of the B to yield AX plus B. Examples, you've got this fluorine gas reacting with sodium chloride, aqueous form. And notice what's taking over what? The fluoride is going to replace the chloride ion here. And now you're going to end up with sodium fluoride, and chlorine gas is going to be emitted. Okay, so it replaced. And your metals are going to replace your metals, and your non-metals are going to replace your non-metals. You're not going to have a metal replace a non-metal. There's another example, magnesium in the presence of hydrochloric acid. You can release hydrogen gas, and notice the chlorine ion displaced, or the magnesium displaced the hydrogen to bond with that chlorine ion. Double displacement reaction. The ions of two of the compounds are going to switch places in an aqueous solution to form two new compounds. So remember, cations always combine with the anions. So whenever you're displacing something, the metal, the cation will always replace the other metal, because you always have to have a cation with an anion in one compound, right? So double displacement, two replacements, or switch. General equation, ax plus by yields ay plus bx. So they switch. For example, iron sulfide reacts with hydrochloric acid, releasing hydrosulfuric acid gas form, and resulting in this iron chloride. That's an aqueous solution. It's still dissolved in the solution, in the water. Make sure that you take a moment. You can stop to identify the types of reactions shown below. You can pause this, go through it, and then I'll show you the different answers. So for number 1, you can see that they combine, so that's a synthesis. Synthesis as in to make something, to combine it. Number 2 looks like the opposite, so decomposition. Number 3, notice that you end up with C displacing, replacing the other one, so this is a single displacement. In 4, notice that it's a double displacement, right? The B and the D switch. I'm just trying to think of that word. Single displacement over here, you can see. And over here, you've got a type of synthesis. They combine. All right, a couple more important ones to know. So whenever you've got an acid and a base, this is a special type of double displacement reaction. We call it, I just call it a neutralization reaction, but your book's going to call it an acid-base neutralization reaction. It takes place anytime you've got an acid and a base that react. All right, so let's look at acid-base chemistry a little bit, and we'll do a lot throughout the year. The products, so you've got an acid and a base, they're your reactants. You're going to end up with some sort of ionic compound that we tend to call the salt, and water. So you always end up with some salt plus water. Water is always going to be a reactant in this product in this reaction. General equation, HA, the H to tell you that it's an acid, right? Plus BOH, the hydroxide, to sort of remind you that it's a base. And they're going to switch, and that's how you end up getting water as always a product, okay? So always a product. That's right, always product. Again, I'm just on my PowerPoint, so it looks terrible. I apologize. Example, hydrobromic acid plus sodium hydroxide, a nice strong acid with a nice strong base. They double displace each other. Sodium bromide salt plus water. That's a neutralization reaction. It neutralizes the strong acid and the strong base to make it more neutral, more even, more like water. Combustion reaction, I definitely want you to know this one. So it's super important just for your life in general. Combustion reaction, you tend to have, it says a hydrocarbon here, but it's going to be any organic compound. So organic compound, meaning it's got carbons and hydrogens, but it might have other things too. A hydrocarbon only has carbons and hydrogens, but organic compounds can have more than just carbons and hydrogens. Anytime you have an organic compound combining in the presence of oxygen, so you always have organic compound plus oxygen as your reactants. And they're going to combust and release a huge amount of energy. This is the basis for the energy that we get from all of our fuels. So our fuels, a lot of which are hydrocarbons. Some of them aren't. Some of them are alcohols. Some of them are, cornstarch. Remember when I burnt some cornstarch there? That was a combustion reaction too. I'll do it again. Reactants are your hydrocarbon and oxygen. At least for you guys, it'll be a hydrocarbon. But like I said, it's pretty much any organic compound. And oxygen, the products are always water and carbon dioxide in different amounts. Sure, so different balanced equations, but water, carbon dioxide, always. General equation, here we've got some hydrocarbon, but like I said, it's not just hydrocarbons, it's organic compounds in general. But this is the part that's always the same. There's always an oxygen present, and together they always release carbon dioxide, gas form, and water. Also usually in gas form because it's so hot that water gets boiled. Here's an example. You've got 1, 2, 3 carbons, meth, prop. So this is propane in the presence of oxygen, releases carbon dioxide and water. Okay? Always. Combustion reactions are super duper important in terms of fuels from your hydrocarbons, but also in terms of fuels from your glucose. C6H12, that's got C6H12O6, that's glucose. It's a type of organic compound. That stuff is the fuel for your cells too, right? So your cells are going to burn that stuff slowly, but still will. And it's still a combustion reaction. Just a very special one called cellular respiration. All right. We'll look at that stuff in a little bit. Identify each type of reaction below. Predict the products for 5 to 7. So I've got this reaction here. Make sure you sort of notice what's going on. Eyeball it a little bit. Ooh, looks like. Oh, let's go through all of them first. Grab a pencil, fill in your notes, and then just start at the first one. See if you notice the sodium products. Yep, looks like they replaced one another. Look at this one. I've got oxygen. In the presence of oxygen, releases carbon dioxide and water. Sounds like a combustion reaction to me. This next one, I start off with a single thing. It looks like it's replacing my metal there. Looks like a single displacement. Here I've got a nice long one. You can probably see it right away if you notice the calcium, what it starts off with. And then what it ends up with. It ends up with what the magnesium it started off with. So that's a double displacement. I've got this ammonium hydroxide and this hydrobromic acid. Sounds like I've got acid-base reaction, neutralization reaction. We'll fill in the products in a second. Barium plus oxygen, probably can predict that these two things are going to come together. And that sounds like a synthesis. Number 7, you only start off with this one big thing. So you're probably going to predict that it's going to break apart into into 2 or more pieces. Decomposition. Number 8, notice you've got solid, lonely little nickel here in the reactants. But notice it kicked out this silver, so it looks like a single displacement. And then notice I've got this hydrocarbon. Again, ethane. Well, this is actually not ethane. This is ethene, but don't worry about that. It's a hydrocarbon. The presence of oxygen produces carbon dioxide and water. And this guy is a combustion reaction. All right, let's start predicting some products here. So this is an acid-base neutralization, which is really just a fancy sort of double displacement, right? So go ahead and double displace. So the positive charged ion, the ammonium right here, is going to replace the other one, right? So they're going to switch, and you're going to end up with ammonium bromide, salt, and water. Barium oxide, just make sure you also balance this equation. So let's balance this equation while we can right now. All right, let's go to 7. We've got this sodium carbonate, probably going to break down. Let's balance that guy out too into sodium oxide plus carbon dioxide. Oh wait, it's already balanced out. Nice. Number 8, oh, it's already, did they just pop up all of a sudden? I didn't notice, I'm sorry. All right, so there you go. You've got, these guys look like they're already balanced out. Make sure you know how to do this.